I'm delighted to introduce Mira Ariel of Tel Aviv University, who will be talking about number words, prototype structure, and density. The floor is yours, Mira.
Thanks very much, Yael. So I want to say that number words are weird, not a very technical term, is it? But really cognitively, what we were meant to do and that we share with the bears and monkeys is to assess approximate quantities and in addition, subitizing very, very small, precise numbers. So precise counting is really sort of a cognitive aberration. It's a young cultural innovation. If you look at Piraha, well, they have something like a bit, a little more, and many, and they make do with that, and it doesn't correspond to any precise numerals at all, and they're just fine. In the end, I'll show you that maybe we're still like them a little bit. Okay, so semantically, I want to say number words are indeed very atypical. They have a discrete and precise meaning, which is not normally the case. They are relatively context insensitive. They're not influenced by their neighbors so much. And so synchronically, they are quite monosemous. And as a result of that, they are diachronically very, very stable. Okay, so if you look at most words, I take this from Pagel et al., they have about a 50% chance of being replaced by a new renewal, by the way, to make it short, roughly every 2,000 to 4,000 years. Okay, so if you look at the word like nice, it started meaning something like not knowing. It got to be the nice we all know and love, and hence, or whatever conjunction you want to use, it was renewed by the word ignorant. Okay, but if you look at, this is a graph of the change of the 200 words on the Swedish list, a pretty prestigious list, very frequent. You see the arrow, that's where number change is. In other words, it's extremely low rate of change. So why are number words so stable? Well, Pagel's first solution is that it's because they're highly frequent. However, the problem is that many atomic numerals are not really nearly as frequent as you would need it to be. The other solution is, well, they have a low ambiguity rate, and that's for sure is true, and it makes sense because polysemy, synchronic polysemy, as we know, may lead to semantic change, which in turn may lead to renewal. So that would be a very good explanation. Whereas monosemous lexical items have an invariant synchronic meaning. So how would it change? The problem is, of course, that monosemous meanings very often turn into polysemous meanings. So once again, we're stuck with a question, why don't numerals become polysemous? It's just a different question, but it's the same issue. So my solution, it's not the end of the puzzle, is that numeral meanings don't have a prototype category structure. So most words have a prototype category structure, numerals do not. So typical lexemes like nice or table have flexible boundaries, which means they can broaden, they can incorporate non-category members into their meaning. So if you say nice, it can be interpreted in context as good or kind or whatever. And they have multiple denotations, partly because of this broadening, and partly because, for instance, nice has many degrees. So they allow for narrowing. Okay, if you have so many denotations, you might want to zero in on a subset of those. Okay, so if you have broadening and narrowing, of course, you have a natural environment for semantic change. And this is why items which have prototypical category structure often enough change. And here is a case in point. So the first one, do I look nice? The speaker means really, do I look attractive for the date? In the second example, you're too nice, your kids are going to take advantage of you. Nice really is narrowed into kind, okay? So the number lexemes, I want to say, are much less amenable to online broadening or narrowing. And they're therefore much less amenable, of course, to semantic reanalysis. But wait a minute, the puzzle is not solved yet. We can push it one step further. So why is it that typical lexemes, but not number words, have a prototype category structure? Okay, so, and this is where my final answer is. I want to say that typical lexemes are members of a sparse lexical field. I'll explain in a minute what that means. Whereas number words are members of a dense lexical field. Okay, so we have nice and six as examples for sparse and dense items. So a lexical field is a set of similar but distinct competitors. Anytime I want to say something, there's competitors to choose from. Okay, so how distinct are these competitors? Well, in a sparse system, they are quite distinct. They may be different on multiple parameters, nice, kind, etc. But when you look at the numbers, the difference is minimal. There's a single parameter. For the number system, it's the +1, which is the dominant parameter. What about the space between? In other words, how broadening can take place? Okay, so if you have a typical lexeme like nice or table, there's a large, what I call no man's land in between nice and kind that nice can encroach on. Okay, but for the number system, there isn't any no man's land between 6 and 7 and 7 and 8. The boundaries for sparse nice are adjustable. It's by default and almost that the boundaries can be relaxed, okay? However, for the number system, they are quite rigid and would take a special mechanism to get rid of. The meaning therefore, of sparse systemic lexemes is context sensitive, polysemous, open to historical change, and the opposite is true for numbers because they're context insensitive, they're monosemous, and therefore resistant to change. Okay, I need to do something here. I don't know how to get rid of this. Okay, so what I chose is to look at broadening processes and narrowing processes for dense versus sparse system members to establish this distinction. And I'm talking about explicit broadening and narrowing. Why isn't my thing working? Okay, so broadening, like I said, means collapsing the boundaries around the category and profiling a whole range of denotations because you're including the competitors. So more or less 17 means 17 plus its dense neighbors. So you start with this dense system and you collapse the boundaries between 16 and 17 and 17 and 18, and you get a range of 16, 17, and 18 because you collapse the boundaries around 17. If we look at narrowing, for instance, pretty as in pretty nice, so narrowing presupposes multiple denotations. Of course, how else would you zero in on some of them if there aren't many? And it picks a subset. So if we start with a typical lexeme like nice, and that's its competitors, there's a no man's land. Okay, so that's a default process of broadening because it's a typical lexeme. But then once we narrow, we also distinguish between a core meaning and non-core meaning. And as it happens, pretty picks the non-core meanings, but it doesn't really matter to me what, as long as it picks a subset of meanings. So I chose 3 narrow words. And as you can see, they're different, a little different from one another. One is mamash, like real or really, day as in pretty or pretty much, and sugshel as in kind of. They do different things, but what I care about is that they pick a subset of denotations. I don't know, I have a problem here. Jack, can you come help? Okay, and I also picked one broadener, the Hebrew approximately or more or less, which can modify expressions. Okay, so what are my predictions? Can you get rid of this, which always gets in my way? Sorry. So my predictions are that when you have a typical lexeme, you don't really need an explicit broadener because by default they are broadened because their boundaries are flexible. But when you have a typical lexeme, and narrowing, it makes a lot of sense because there's too many denotations. You may want to zero in on a subset of them. Now, when you're talking about a numeral, narrowing makes no sense because there's only one denotation. What will you zero in on? Okay, wait. Okay, I'll live with it. Sorry. Okay, when you have a numeral, on the other hand, broadening makes sense because it's so such a single denotation. You might want to refer to a range. So you may very well want to broaden it by using an explicit broadener. So these are my predictions. Now let's look what happens. So first, just a general comparison of the 3 narrowers versus a broadener. As you can see, the 3 narrows I picked are way more frequent in Hebrew 1010, which is a very large corpus, mostly written. And I picked a typical lexeme. I picked rek, empty, just because it has a precise meaning, so people don't tell me, oh, nice is graded. So I picked something that has a precise meaning. And as you can see, the frequency is pretty much the same. When you look at numbers, however, as you can see, they stand out very much. It's the opposite pattern. Okay, so if you look at the explicit broadener, as you can see, numerals take it 10 times as often as the typical lexeme. But if you look at the narrowers, it's just the other way around. In other words, typical lexemes take narrowing much more often than, than the numerals, okay? So you can also make comparison like this. If you look at the typical lexeme, you can see it likes narrowing far better, far more than broadening. And if you look at numbers, they like broadening far more than narrowing, okay? Okay, but I want to go beyond row counts. That's one of the dangers of large corpus searches, such as Greece and David, who worked on sort of and kind of, and I think fell for just looking at numbers. So there are various problems with just looking at making counts in corpus, and I'll go through a few of them. Okay, so the first thing is that there's a difference between interpretation and distribution as collected by just a blind corpus search, such as Sketch Engine, as I used. So if you look at 16% more or less, notice that what you get is an interpretation that includes precisely 16. In other words, there's a range, 15 to 17, let's say, 16 included. Okay, this is with the more or less, which is what we would expect. Now, what happens when you have a more or less modifying a typical lexeme. He used it as more or less bait me to do the job. This is a different interpretation that we get here. We do get a range around bait, but most crucially, it excludes precisely bait. In other words, when you modify a typical lexeme with a broadener, such as more or less, often enough what you get is narrowing and not broadening. So we must not confuse the function of the explicit marker as we think of it and the function it actually performs. Next, there's, we can jump from adjacency to modification. So you have mamash, it's a narrower here, and it's adjacent to millions, but actually it modifies at this time. Okay, narrows can have a different function. Okay, so what I did is I have to fight my computer. Sorry, I'm going on.
Hurry up, yeah.
Yeah, okay. So next, some number expressions are actually members of typical sparse system. They're not part of the dense system. So they were mamash 10. 10 here means excellent. Okay, so if it's a typical lexeme, it has multiple denotations, of course, it should get a narrower. Same thing with what I call Stancy ballpark number construction. This is a fancy name for calling expressions such as dozens and millions. Okay, these are really outside the dense number line, and as such, they are sparse system members and they have multiple denotations. So what happens if we eliminate all these cases? Well, if you look at count, we are down to 0%. No count numbers were explicitly narrowed in Hebrew 1010. But wait a minute, I cheated.
Mira, you have to hurry up. Your time is up, but okay, so.
Really?
Yeah.
Okay, sorry. Okay, so, well, all numbers are not equal. Specifically, measurement phrases are different because mesh entities have no natural counting units, so we quantize them with the help of measurement units. But measurement units like liter and kilogram are, of course, sparse system lexemes. So what the question is, do numerals with measure phrases have multiple denotations? Do they behave like lexical, like typical lexemes? Okay, as you see, well, 48 of them did get narrowers. Is that a lot or a little? Well, it's rather little because I estimate that there are like 1,750,000 measurement phrases. So we're talking something that is very, very rare. So to go back to the predictions, and here are the results. So indeed, typical lexemes rarely get broadeners, and moreover, the way they're interpreted is really as narrowed, whereas numerals do get narrow, of course, narrow, oh, sorry. I'm sorry, I don't know what happened to me here. Okay, sorry. So numerals do get narrowers, but it's not only rare, it's actually limited to measure phrases. So I want to say that numerals are atypical, not a dense system lexemes. I won't repeat the features, I'm sorry. But I want to say that when you look at the last feature, argumentatively useful, I think typical lexemes are much more useful, actually. So this is a favorite example of mine where the speaker says 24 years. This is precise and wonderful and informative. But then she goes on to say almost half of a jubilee. Okay, this reminds me of the Piraha who make do with relative quantities instead of precise quantities. Thank you. Sorry for going over time.
Okay. There is nothing in the Q&R, but there might be things in the chat. or we'll simply look at whoever raised their hands. Mira, can you take off your
how do I do that? Okay, sorry.
No, yeah, okay. Hands up, no hands up. If there are no hands up, I'll take the privilege. I think we discussed it once, but I don't remember the answer, and the others haven't heard the question. So there are numbers that stand for concepts. Something like you get a driver's license when you're 18. So if somebody is a policeman holds me up and asks, I'm white-haired, but you have a driver's license, I can say I'm over 18, or not over. She's 18, I believe. Okay, so and she can be 20, and you will still be saying something which is true. So there are numbers that stand for concepts. Would you expect them to be broadened and narrowed accordingly because of the context?
Absolutely, yes. But I think you're asking, what you're talking about are two different things. You don't have to be what I call a number with a personality. Okay, I didn't talk about it today. Okay, but like 7 in the Bible is a number with a personality. Okay. So those are really stand for what I say unitized concept. They have a double life. They are part of the dense system, as well as shifting to a sparse system, in which case they behave like typical lexeme. So we have a baker's dozen, which is like 13, a couple of minutes, which is like a few minutes, 7 standing for many in the Bible. So that's one question. Okay, so we have unitization, which pulls the number outside the dense system. It's no longer minimally different from its neighbors, and hence that's what I expect, and that's how it behaves. That's one thing. Another thing is, it doesn't have to, like the driver's license example that you gave, we can use anything. I can use the word computer to mean at least a computer. So contextually, we can use any expressions to be interpreted in context as at least, or at most, or approximately, okay? But the numeral itself is precise.
I see one more hand. Okay, Natalia.
Thank you very much. Yeah, thank you very much for this amazing presentation. It's totally new perspective to me. And I was wondering, maybe it's a totally crazy idea. Can one extend this approach to like lexicon in general and say, look at the semantic structure, clusters, and similarity between words and their neighborhood? And can one then probably, I don't know, infer which of them have higher chances of being stable and which can be reduced more often? So if it's high density neighborhood, then they won't be reduced, they will be more stable, something like this. Or do you think it's totally crazy?
Mira, a very short sentence because we have to go on with the other one. So a yes or a no?
It's not crazy at all.
Well, okay, so was it a no or yes? It's applicable. In answer to Natalia's question.
I haven't done it, but it should be done.
Okay. It's okay. You can go.